postulate, 5 theorems that we're going to talk about. So this postulate, remember, means that we have, here, go up to your mouth. Means that we know it's true, but we don't have proof that it's true. We can't prove it. We just know that it's a fact based on how it looks. Okay? So, here you go, Lukeman. Angle addition postulate says point D is the interior of angle AKC if and only if measure of angle AKD plus the measure of angle DKC equals the measure of angle AKC. So we're going to start with the angle AKC. So we're going to draw any angle there. I'm going to make it kind of obtuse, that way it's a little easier to work with. All right, we have 3 points on the angles. We have A, K, and C. Does anyone remember which one has to be in this certain place? It's been a while since we talked about angles. Which one has to be the vertex? The middle, and which letter is going to be your middle? K, good. So K, and then it doesn't matter which one is which. So I'm going to do A and C. Now it says that point D is on the interior. What does that word interior mean?
Inside.
Inside. So somewhere inside here we have point D. I'm going to throw it here. Point D. So pretty much it's just saying if I have an angle or a point in the middle and I can draw a line through that. Morning.
Sorry, it's because I went to go get breakfast and the line was so long.
I'm sorry. Okay. And what that's saying is if I take one angle and I add it with the other angle, it will equal the whole angle. So I'm going to color code that. I'm going to be color coding a lot today. I'm going to just try and use 3 colors. I'm going to use green, blue, and orange. So if you just want to grab 3 colors out, doesn't have to be the same 3 colors as me, so I know I have to restock some of those bins. I'm using green, blue, and orange. Marianne, here you go. Where did I just put them? Right here. All right, so as we take a look at this first one, I have AKC is my overall angle. I'm going to do that one in orange. So I have A to K over to C. And really what this is just saying is if I have 2 angles that are next to each other, when I put them together, it's going to equal that whole thing. So if I have AKD, I'll do that one in green. So that's this first angle, A to K to D. Here you go, Ada. Yep. And then I add it with DKC. This other angle here. Okay, and what it's just telling me is if I do the green amount and then I add onto it that blue amount, how much have I totally gone? I've gone all the way from A all the way over to C. So together that green and blue is going to make that orange that whole way. All right, we're actually going to jump down to the vertical angles theorem. This is one that we know, but we haven't talked about in a while. Vertical angles theorem says if two angles are vertical, then they are congruent. If two angles are vertical, then they are congruent. So what does vertical mean again? Vertical is like up and down. So when we talk about vertical angles, they're angles that are... Here you go. Ishmael. Angles that are across from each other. So it's kind of like when I have two lines that cross. Okay, for today we'll just number our angles. That way it's a little bit easier. So we'll say angle, 3, 4, 5, and 6. I don't know why I started at 3, but my brain just did. So which angles are going to be congruent here? Angle 3 is congruent to angle, what's the one across from it? 5. Those are vertical angles. What other angles would be the same?
4 and 2.
Good. 6 and 4 or 4 and 6. Morning, Nara, here you go. All right, so as we look, the next ones we're going to do the supplements. So next we have supplements. We have a supplement theorem and a congruent supplements theorem. It's a little goofy. They're very similar, but a little bit different. All right, for our supplements theorem. Supplement theorem says if two angles form a linear pair. What does a linear pair mean again? What's in that word linear? Line. So they form a line, then they are supplementary angles. So if I have a line, just a nice straight line, there's my line. And I have two angles that are next to each other on that, so I'm just going to make an angle somewhere there. Didn't have to be like that. Could have been facing the other way. Could have been straight up in the middle. Somewhere in between. So now these angles that are next to each other, we'll go back to angle 1 and 2 now, I guess. Angle 1, angle 2. I skipped it before, so. If I see that they make a line, what do I know about those two angles? If two angles make a line, that means that they add up to, how much is the whole thing going to be? 180. And if two angles add up to 180, that means that they are supplementary. Yeah, if you fill a pass. All Alright, so if you want to color code these, you can. You can do angle 2 in green. Supplementary means that they add up to 180. That's that definition. So we would write out for our work here. Measure of angle, what's the first angle? 1, right? When I add that to the second angle, measure of angle 2, together, because they form a line, and we know a line is how many degrees? 180. And anytime that two angles add up to 180, that means that they are supplementary. So that's that theorem. It's just saying now we're using that definition, combining two definitions into a new theorem. Our one definition of linear pair, and then our one definition of supplementary. We're just combining them, saying, yep, if it's a linear pair, then it's supplementary. Yeah, that's not a door. It's confusing, isn't it?
You can't open it?
No, I can't either.
Why?
Because it's supposed to be just like a wall now.
Oh.
It's cheaper to put a door there that no one can open than a wall. Who knew? All right, number, I don't know, 3, 4. I don't know. These aren't numbered. I don't know. I said numbered. Ah. All right, congruent supplements theorem. We're going to go below this. So we're talking about supplements. We know supplementary means that they add up to 180. So this one's kind of goofy. The way it reads is a little silly, but we're going to talk through it. Remember, phones should be put away because we're writing kids up for phones today. Ishmael, Ishmael, Ishmael. Not even listening. All right. Angles that are supplementary to the same angle are congruent. So this, again, feels a little silly. I don't know. It's kind of silly, but it makes sense. We're actually going to prove this later on because it's a theorem, so we can actually write a proof to show why it works. All right, so supplementary means that they add up to how much? 180. So we're going to just come up with some random numbers. We're already at, 8, so let's go to 9. So measure of angle 9. We're not at 8, we are at 6. Oh no, that's going to drive me nuts. We'll come back to 7 and 8, I guess. Plus the measure of angle 10. Okay, those equal 180. But now we're going to have a new supplementary angle, but it's supplementary with one of these. So let's match it with angle 9. If I say that I have angle 9 again, but now I have a different angle, angle 11. And it still equals 180 degrees. Ishmael. You're one away. It's gotta be away today. You're being strict about it. Thank you. Alright, so if I have two numbers that add up to 180, I keep one of the numbers. Do these numbers have to be the same in order to still equal 180? No? Let's say angle 9 was 100 degrees. What would angle 10 have to be? 100 plus what is 180? 80. But now when I go to the next one, angle 9 is still 100. 100 plus what is 180? 80. There's only one number that when I add it with the same number that would equal 180. So because these two match, we have this angle 9 and angle 9 match. Those are equal. They're the same number in both situations. And in both cases, they equal 180. What ends up happening is these middle ones, these angle 10 and angle 11, these have to be the same. So that's what this is saying, is that they're congruent. Angle 10 has to be the same as angle 11. In order to make both of these statements true, these would have to be the same numbers. All right, you guys are crushing it. We got 2 more, and then you have a 2 problem practice. All right, these ones are really, really similar to these ones. In fact, if you look at the names, what are the only differences going to the next one? Instead of supplement, we're talking about complement. Supplement meant that they added up to what? 180. So if you wanted to put that there, I wrote it in colored pencil, but if you want it again, 180. What does complement mean? They add up to just 90. So in this case, we have 2 angles that form a right angle. Then the angles are complementary. So again, we're just taking 2 definitions that we know. We know what right angle is. We know what complementary angles are. We're kind of including that angle addition postulate. Now if we put 2 angles together and they make a right angle, that means they make 90. Okay? So this is, again, I don't know, these are kind of goofy. I think they're a little goofy, these ones. We need to state them so we can use them. But this is something that you've already known. We've already actually done this theorem in class with the numbers. We just haven't done it with proofs. Okay, so I have a right angle to start with. How do I show to my reader that that is a 90-degree angle? Because I know for a fact that's not exactly 90. Good, that little square in the corner. All right, but now I have 2 angles that are going to create that. So I'm going to draw a line somewhere, an angle in the middle. Doesn't matter where your angle is. I'm going to go a little down this time. And we'll go back to angles 7 and 8. So this is something that we did back in chapter 1. I gave you like the measure of angle 8. If I said measure of angle 8 is 20 degrees, how much would angle 7 have to be? 70, because together they have to make 90. You knew that. Now we just have a theorem saying that. Okay, so we're taking this top angle, angle 7. We'll add it with that bottom angle, angle 8. And together they have to make how much is the whole angle? 90. We know it's 90 because of that box there. It tells us it's 90 degrees. So if you want to write that out as a math term or a math sentence, we should measure of angle 7. When I add that with a measure of angle 9, not 9, measure of angle 8, together those 2, because they make a right angle, add up to 90. All right, we have one last one. This one again is really similar to the congruent supplements theorem, but it's congruent complements theorem. So what this is saying is we have angles that are complementary to the same angle are congruent. So if I know two angles add up to 90, but one of those angles adds up to 90 with another angle, those other angles are going to have to be the same. And really it's the same setup as our supplementary angles here. So I'm going to say, what number are we on now? 12? Measure of angle 12 plus measure of angle 13. This time they're complementary, so they add up to 90. Okay, now if I take 12 again and I add it to a different angle, and it adds up to 90, so I'm going to do 12 and 14. Remember that M stands for measure, so the amount that they are. If 12 doesn't change between these two sentences, the number we add to that is going to have to be the same. So if I say angle 12 is 50 degrees, trying to make a simple problem here. 50 plus what is 90? 40. Now we have 50 again. Is there any other number I can add to 50 to make 90? No. So because there's no other number that works, it has to be 40. That means these two have to be congruent. They have to be the same. They're going to end up being the same number, the same amount, and the same amount means that they are congruent. Okay, if it helps you to color code it, you can. You can like circle these saying they're the same. So I really lightly circled 13 and 14 and just put an equal sign between them. All right, I'm still going to wait to glue this in just a moment because we're going to use this for proof. Hi, welcome. How are you? You can have a seat right here. Over here. Perfect, thank you. So quick, Lickman. I know, wouldn't that have been exciting? It would have been really early today. Hi, we have one more problem and then we'll hang up. You're crushing it. All right. So we have one problem we're going to do. This one is a 5-step problem, but it does take up kind of a lot of space. So either if you glued this in already, that's great. You're going to have to glue it in sideways. But then you're going to have to do the proof on the next page. Or if you do the proof on this page, this will have to get glued in on the next page. So it's kind of up to you. Do you want your theorems first and then an example? Or do you want the example and then the theorems? I'm going to just do my example here right away. And then I'm going to glue this in on the next page. Okay. All right, so our only problem today is we're going to write a proof of the congruent supplements theorem. Write a proof of congruent supplements theorem. When we write a proof about a theorem, what that means is we can't actually use the theorem to prove it. But we're going to start with the if and then do all the connection points to the then, and then that way we know the beginning and the end. Okay? All right, so we're going to do a 2-column proof. Left side as always. Statement. Right side is reason. And our first reason is always given. Now you're probably like, what the heck is given, right? All it says is write a proof of the congruent supplements theorem. So I'm going to take this, I'm going to put it up here. Is that okay if I cover up the top a little bit? All right, so our congruent supplements theorem, nope, don't know how that's going to work. I'll just cover it up for a second. It says angles are supplementary to the same angles are congruent. So angles that are supplementary to the same angle are congruent. So we're starting with angles that are supplementary to the same angle, and then in the end, we're going to prove that they're congruent. And we kind of already showed our work for this. So in this work, we started with angle 9 and angle 10 are supplementary. So that's what we're going to go with for step number 1. We know that angle 9 and angle 10 are supplementary. Hopefully you're writing smaller than I am, otherwise it is going to take up some space, but we only have one problem today. Okay, what other angles did I have to say were supplementary? We need 2 sets of supplementary angles. But we want one of them to stay the same. So when we did this one, I picked angle 9, not I did. Because I just wanted to keep the first one. So we're going to say angle 9 and angle 11 are supplementary. And that's still part of our given. What we're trying to prove is that angle 10 and angle 11 are the same, that they're equal. So this is going to be about a 5-step proof. Got 1 step done. So based on just this information, what's the next thing that we can say that we haven't said yet? What does that word supplementary mean? Whoa. Supplementary? Means they add up to 180. Good. All right, so measure of angle 9 plus the measure of angle 10 would equal 180. All right, then we know that the measure of angle 9 plus the measure of angle 11 equals 180. We need our reason. There is only one word that told us that. So if it's a word that tells us that, usually that tells us it's a definition. So definition of what word? From number 1. From number 1? Supplementary. All right, so step number 3. I'm going to actually skip a line real quick for 3. Go down 1 line just to show some work here. I knew that measure of angle 9 plus measure of angle 10 equals 180. What else equals 180? What could I replace 180 with? What other 2 angles? 9 and 11, because this side is 180. 9 and 10 is 180. Now 9 and 11 are 180 also. So we know that they're equal. So what do you call that when we switch something out for its equal part? Good, substitution. If you think about it in volleyball, basketball, football, sub means that you're subbing out, you're switching someone out. Sounds good. Thanks for writing. Getting most of the information. Okay, but when you switch someone out, you want to switch out somebody that's equal. Someone that has that same amount. All right, eventually we're just trying to get to 10 and 11. So what do you notice about our equation here on both sides? What does it both have? Angle 9. Can I undo adding angle 9? Yeah, how would I undo adding? Subtracting. So subtract measure of angle 9. And I can do that as long as if I do it on one side, do it on the other side. So for step number 4, we used to break this into 2 parts. We used to call that subtraction, and then this next one substitution. We're just combining them, making it a little simpler. I got rid of angle 9, so what's left? Angle 10 is equal to, what's left on this side? Angle 11. So for step 4, we'll say what we did. What was that operation? That was our subtraction property. Okay, but if I go back to my supplements theorem didn't say that they were equal. It says that they are congruent. If I know they're equal, does that mean they're congruent? Yeah, that's what it means. Good. So step number 5. Angle 10 is congruent to angle 11. And again, there was only one symbol or one word that told us, and that was that equal. Equals means that they are congruent. So that's again another definition.
You went all the way down to the 400th bathroom.
Oh my gosh.
Why are you lying? Bad kid.
I don't know.
Don't let him go to the bathroom again.
Never.
Why are you lying?
Definition of, and this is going to be our congruent angles. Give me 2 seconds, Ishmael. Congruent angles. All right, that is it for our notes. That was kind of a lot, I know. We still do have about 10 minutes. There's 2 problems of practice. Now, what I'm noticing is that sometimes when we get to practice, these practice problems don't look exactly like what we just did in the notes. So you're probably like, what the heck? Miss Merle's making us do problems we haven't even done together. That's because with proofs, once we do one type of proof, you've done that type of proof. I just can't have you repeat the same proofs over and over and over and over again. So they do look a little bit different, but you can do it. You have the skills. It's like a puzzle. You guys are very, very good at puzzles. I've tested you. You got it. All right, so practice is in Schoology. It's 2 problems. They're drag and drops. Let me know if you have questions about them. Otherwise, the rest of the time is for you to work on that. And then if you didn't get yesterday's practice done, today would be a good day to get that done too. This is due Monday, and then when is your test? Wednesday. Next Monday and Tuesday.